What happened on the Kamchatka Peninsula? We have dug deeper than anyone else and found something that no one else has found. The area we have investigated is a lot like a colander. All pollution leaks into the Pacific Ocean, an extremely dangerous substance. So what do we do with all this knowledge? Hello, friends. We were all waiting for this. You were all waiting for this. Everyone was waiting for this. And finally today we are going to talk about Kamchatka and only about Kamchatka. It's been a long time since what happened on the peninsula during the autumn of last year. So first, I want to refresh your memory. Then I will talk about our expedition, and after that I will share my version of what is going on. Let's begin. In the autumn of last year, an ecological disaster occurred in Kamchatka. After a storm, a large number of mollusks, sponges and echinoderms washed up on the Khalaktirsky Beach and the Avacha Bay. Moreover, surfers from several training bases on the Khalaktirsky Beach have experienced poisoning after contact with the water. At that time, the most common symptoms were dryness of mucous membranes, burning sensation, headache, nausea and vomiting. Russia's surfing champion Dmitry Ilyasov was diagnosed with a chemical burn of the cornea. It became apparent that one of the few Russia's beaches that is suitable for surfing has been lost either for the season or even for many years to come. The situation started to evolve pretty fast. Several groups of scientists, employees of governmental environmental protection agencies and non-governmental agencies arrived in Kamchatka. The race was on. Everyone began collecting samples, trying to determine the causes of the disaster. The initial tests of the water have shown an excess amount of petroleum distillates, phosphates, and phenols. Various hypotheses of the natural and anthropogenic causes were proposed, yet eventually the scientific community has come to blame everything on the so-called red tide, and the public discussion gradually muffled. At about the same time, I got my hands on samples of the water, soil and marine life that were collected by the staff of Alexey Pivovarov's redactor. Traces of the decomposition products of the very toxic substance, the rocket fuel, heptyl, or UDMH, unsymmetrical dimethylhydrazine, were found in one of the water samples collected by Elena Svetikova at Bolshaya Lagernaya Bay. In one of those samples you brought over and gave me, we have found decay products of the rocket fuel. Just finding such substances alone, even disregarding the recent events, is a full-blown emergency in and of itself that warrants an additional investigation. Additionally, in my understanding, it was a mistake to brush off so lightly other potential sources of technogenic pollution, the way the other colleagues from the Russian Academy of Sciences and environmental departments have done. These potential sources of pollution are in no short order in Kamchatka. In fact, there's a whole plethora of them, and practically no knowledge of how to manage such sites or understanding of their current environmental and geological processes. And so we have collectively raised almost 2.5 million rubles. We organized an expedition to understand the scope of the rocket fuel pollution as well as to explore other potential sources of technogenic pollution. But most importantly, we set out to answer the main question: what actually caused the death of aquatic life forms and the poisonings of surfers in the autumn of 2020. As we were preparing for the expedition, we marked 22 sites on the map that pose a threat to the environment of the region. Those sites included household waste landfills and hazardous waste sites, rocket military bases, Navy and Army warehouses, wastewater treatment facilities, and other potential sources of technogenic pollution. The complete plan was to study all those mapped sites in the field, to collect samples and to determine by analytical and laboratory methods the specific substances and the paths by which those substances could have gotten to the Khalaktirsky Beach and to the Avacha Bay areas. In addition, it was necessary to estimate the initial volumes of those substances, the degree of their toxicity, in order to establish the main thing: what substance and in what quantity was able to spread through the entire territory in question and to lead to such sad consequences. After setting our goals and meticulous laboratory prep work, we set out on our expedition. Upon our arrival at Kamchatka, we went first thing to the shore of the Большая Лагерная Bay and began studying the area where the dimethylhydrazine was previously found from the land and the sea. On this spot, Lena from Redakция team collected the sample in which dimethylhydrazine was found, right here from this very bridge. Now we will collect the sample here as well. This is a mandatory item on today's to-do list. We've seen your YouTube videos! Thank you! We went into Malaya, Sredняя and Большая Лагерная Bays by a motorboat and collected samples at those spots. Soil and surface water samples were collected on the shore. The result was an array of samples that were carefully prepared for transportation and sent off to laboratories in Moscow. Two theories of these substances' source in the water were tested. The first theory was that dimethylhydrazine could have been buried in Lake Bunny and then via the Безымянный Creek it could have gotten into the Большая Лагерная Bay. The fact is, not far, just northeast from this area, there was an air defense rocket military base, and as it was closed down, the military staff could have simply thrown the fuel barrels into the lake, and over time those barrels began to leak. The second theory of the source has to do with the Navy base located in nearby Viluchinsk. In 2015, the military already had a leakage of dimethylhydrazine there. This was even confirmed by the authorities of Kamchatka back then. Fortunately, neither theory got confirmed. The content of dimethylhydrazine decomposition products in all samples listed was below the detection threshold. Simply put, even if some kind of a leak did occur, it was not on the scale that could have led to the consequences that were observed in the autumn on the peninsula. Besides, the nature of the current in the region is such that if dimethylhydrazine did turn up in the Avacha Bay only, then it could not have drifted up north and poisoned the sea bottom in the Khalaktirsky beach area. Just in case, in order to ensure the correctness of the conclusions, a few more controlled tests were made for the rocket fuel decay products aniline and xylidines, here at these spots. The result, thank God, was the same. I can definitively state that we dealt with a one-time leakage of the rocket fuel and not with a large-scale spill that could have poisoned the entire district. The next stage was to study the shore of Khalaktirsky beach from the sea and from the land. Using the boat, water samples from the surface as well as from the depths of 20 and 40 meters were collected, here at these spots. Aquatic life forms from the bottom of the Pacific Oceans were collected. A whole panel of land sites that pose a potential threat to the sea water and its inhabitants was investigated. It suddenly became clear that the area of investigation in Kamchatka is a lot like a colander. There are at least 3 landfills that leak into the Khalaktirsky beach from the land, not far from the place where our surfers are trained. There are 2 landfills with household waste and 1 waste site with toxic pesticides. Let's review each site one at a time. Let's start with landfill number 2. Before traveling here, I found the news from August 26, 2019 on the official website of Kamchatka region, where the Kamchatka region head of the Agency for the Waste Management, Andrei Kudrin, declares that this landfill is no longer accepting waste, which allegedly was possible due to the installation of new waste processing plant. It turns out that this landfill is in fact still accepting waste presently, and you can pay with tokens or using an account. Locals say that you can simply drive a dump truck of any garbage and unload it for cash. I really don't know if they're telling the truth or not, and if they're not lying, then is it possible to just dump here a barrel of any toxic waste? What do you think? I'm now standing near the landfill number 2. There is household waste here that is not even covered with soil. The Prelivnaya lake is just below down there, which in turn flows into Pacific Ocean near the Khalaktirsky beach. This means that all the rainwater that flows through the landfills, the leachate ultimately ends up in the Pacific Ocean. See what happens when the waste is not covered with soil. All ravines and slopes are covered with plastic bags and littered with garbage. If we go out there, we will see an entire gorge filled with trash. All this trash gets scattered by the wind, birds or dogs through the area and even beyond. So, as I understand, this ditch is the border of the landfill. We can see garbage being scattered around and flying some dozens of meters beyond the border. We have collected samples at the foot of the landfill, directly from the Prilivnaya lake. Oh my god! Did you get it? I got stuck! Did you get the sample into your boot? Samples collected from where the brooks with the leachate water flow into the Prilivnaya lake had levels of boron 4 times higher than maximum allowable, copper 2,500 times higher, iron up to 5 times higher, manganese up to 84 times higher, molybdenum up to 57 times higher, nickel up to 19 times higher, zinc up to 65 times higher, and vanadium up to 17 times higher. Then, comparatively speaking, almost negligible violations of aluminum levels exceeding the norm only up to 3 times, lead up to 3 times, chromium, titanium, strontium, you know, a joke of a health hazard. In short, it probably is easier to list the heavy metals whose concentrations were not exceeding the safety limits. Once again, all this nasty stuff flows into Khalaktyrsky beach without meeting any defense line at all, and by any means the content of the leachate does not support the statement that the only waste of the 4th and 5th hazardous substance categories is buried here. This is simply not true. They bury all kinds of waste here. The situation with the landfill number 1 is very similar. It is located a little bit farther to the north, and the entire leachate drains through its northern ridge into the Pervy Creek, which again flows into the Khalaktyrka River, and all pollution, following exactly the same scheme as with the landfill number 2, sooner or later ends up on the Khalaktyrsky beach. So this is what it looks like when a stream of leachate at the foot of the landfill flows uncontrolled into the river. Somehow, it's not yellow. What do you mean, not yellow? It's really fucking yellow, my bad. Here, the chemical composition is about the same as above, except the copper content here is not at 2,500 TLV threshold limit value, but only at 180. However, there are traces of chrome, an order of magnitude more than of iron, and lots of phosphorus. Both of these landfills in their current state are a colossal threat to the environment of the Kamchatka region. If dangerous waste should be dumped here, it can easily cause something similar to what we have observed in the autumn of 2020. But the most important site that was investigated inside and out is not even these landfills, it is the toxic waste site itself. At least that's how, for some reason, it is described. In fact, this is practically the same sieve like each of the 2 previously mentioned landfill sites. Unlike both previous landfills, where one can only guess whether toxic waste is buried there or not, here it is guaranteed. It is buried here, and in huge amounts. The Kozelsky toxic waste site was created in Kamchatka in 1979. In those years, more than 100 tons of toxic hazardous chemicals were brought here, some of which are prohibited by the Stockholm Convention and other international documents today. Some stable organic pollutants in there are potentially able to poison the entire northern part of the Pacific Ocean. In 2006, Anatoly Fedorchenko, a representative of the company Nedra, which at that time was engaged in investigation of the landfill, has mentioned this situation in his comments. Reclamation and recultivation work on the Kozelsky toxic waste site was subsequently carried out in 2010 to have the site brought up to the standards. However, the toxic waste site still remains the same colander it was before, and the leachate still seeps into the top layers of the underground water as it did before. And of course, ultimately, all pollution accumulates in the Pacific Ocean in the Khalaktyrsky beach area. I'm tired of repeating this phrase today already. So, what did we do to study the toxic waste site, and what did we ultimately find out? Right now, we are at the Kozelsky toxic waste site. We want to collect water samples from the observation well to find out whether the containers with pesticides leak. At the toxic waste site, we conducted experimental filtration work, georadar measurements, and injected the tracer to determine the areas where the groundwater enters the surface waters. We also collected several water samples from the well. The following day, we collected samples of water and sediment layers from the creeks and small rivers which are located downhill from the toxic waste site. And then we went out into the ocean and collected water samples in front of the Kozelsky toxic waste site from different depths at different distances from shore. This sample array was the result. Our analysis was aimed to not only identify chemical elements, but also to detect specific chemical substances using the most modern methods such as gas chromatography mass spectrometry, together with the laboratory of the Moscow State University Department of Chemistry. We managed to find out not only traces of pesticides, but also the main chemical agent, which, as I understand, poisoned the entire site. I have here in my hands a 100-page report drafted by the Moscow State University Department of Chemistry. This is truly a doctoral thesis. To those who think that this investigation took us too long, I can only say one thing. A real thesis can take anywhere from 3 years to infinity to write. We have done this work in 3 months. This is not just a set of standard laboratory tests, but a true scientific research, because we drilled deeper and found things others did not, or perhaps they did and simply hid the results. You can find the link to the full text of this report in the description to this video below. If you have comments on the content, please send them to the email which you see right here. You can also find it in the description of this video. And now let's briefly go over the results of our research at the Kozelsky toxic waste site. First, we found the pesticide lindane, also known as gamma-hexachlorocyclohexane, in the groundwater directly underneath the Kozelsky toxic waste site. The World Health Organization classifies lindane as moderately acutely toxic. In the US, this insecticide is classified as an extremely dangerous substance. The production and use of lindane in agriculture is forbidden by the Stockholm Convention since 2009. Today, this substance may only be used in medicine or science. However, not only lindane was discovered in the groundwater underneath the Kozelsky toxic waste site. We've identified both the parent material, gamma-hexachlorocyclohexane, and its byproducts of synthesis, even more toxic alpha, beta and delta isomers. By the way, methods available in Russian laboratories do not allow detecting the delta isomer. To identify it, we had to use methods borrowed from our foreign colleagues. Let's see what is so dangerous about lindane for the environment and humans. Why was it banned? For humans, it causes a burning sensation, itching, rash, and dryness of mucous membranes. In addition, large amounts of lindane can damage the nervous system, causing headaches, dizziness, and even death. For the environment, lindane is a persistent organic pollutant which can accumulate in soil or biological organisms for years and even travel with precipitation over long distances. The cherry on top is that in 2005, the U.S. Department of Health and Human Services said that lindane may reasonably be anticipated to cause cancer in humans. The second pesticide we found was hexachlorobenzene. The substance is also prohibited by the Stockholm Convention. It causes changes in the liver, central nervous system and cardiovascular system in humans. It is a toxin affecting multiple organs. It was found in 2 samples taken in the Izvilisty Creek area downstream from the Kozelsky toxic waste site. The last substance we found is called 2,4-D. It is the most important for our investigation, not the pesticide itself, but rather products of its decay, namely 2,4-dichlorphenol. Let me just read the classification and labeling of this substance. The substance is harmful if swallowed, toxic on contact with skin, causes serious skin burns and eye damage, damage to the central nervous system, may cause damage of the respiratory tract if inhaled, and finally is very toxic for aquatic organisms with long-term consequences. We found 63 micrograms of dichlorphenol in 1 kilogram of soil from the Kozelsky toxic waste site. Different organizations declared that the total concentration of phenols in the seawater exceeded the maximum allowed concentration by up to 4 times, causing the death death of sea organisms and the poisoning of surfers. But for some reason, no one tried to investigate which phenols were present in the environment. We figured it out. If someone still has doubts, I will try to dispel them. The maximum allowable concentration of 2,4-dichlorphenol in seawater is 1/10 microgram per liter. We found 63 micrograms per kilogram in soil. I brought the sample of soil taken near a creek between the Kozelsky toxic waste site and the Khalaktirsky beach to the laboratory. It weighs approximately 2 or 3 kilograms and contains up to 200 micrograms of dichlorphenol. It is sufficient to effectively poison up to 2,000 liters of seawater. And this is just a small trace in a small sample of soil. Initial amounts were several orders of magnitude larger. One 50-kilogram bag of this pesticide can poison up to 500 billion liters of seawater. This equals to 200,000 Olympic swimming pools, which in my calculations is exactly equivalent to all the poisoned area of the Kamchatkan nearshore waters. I repeat, just one bag of this pesticide is enough to kill all sea organisms in the area that you see on the screen. There are several thousands of such bags at the Kozelsky toxic waste site. It is highly likely that 200-liter barrels with liquid toxic chemicals are stored there as well. When I calculated the contaminated area, I deliberately assumed that the distribution of dichlorphenol is even throughout the water column. But in reality, the density of the substance is higher than seawater. So this pesticide gets deposited on the seabed where its concentration exceeds the maximum allowable concentration dozens of times, enough to instantly kill all of the seabed inhabitants, and as waves hit the coast, poison all people on the shore. I understand that the information presented here is quite complex and contains many scientific concepts and terms. I will try to explain in simple words, step by step, what I believe happened in Kamchatka in the autumn of 2020. Because of seismic activity usual to Kamchatka, simply put, earthquakes, or with the passage of time, the protective layer of clay at the Kozelsky toxic waste site was disrupted and pesticides leaked into the groundwater. Perhaps the protective layer of clay had deteriorated even earlier, maybe a year or several years ago. But this time, a vessel containing pesticide 2,4-dichlorphenol got damaged. In fact, this does not matter. In any case, traces of this pesticide tell us that there was a leak from the toxic waste site. But only the authorized agencies can tell how exactly it happened after the proper examination of the site. Now let's get back to our scenario. After the leak, the contaminants made it to the groundwater and started to flow towards the Khalaktirsky beach. Part of the stream forms small creeks on the surface and leaves irrefutable proof of what has happened. But the main stream of groundwaters drains directly onto the Pacific Ocean's seabed, according to the theory put forth by Irina Perminova, the professor of the Department of Chemistry. The contaminated area grows, gradually poisoning sea inhabitants, and starts to shift south towards Avacha Bay, driven by the current. Then a part of the contaminated area is diluted with the waters of the Pacific Ocean and shifts further south towards the Kuril Islands. A contamination enters into the Avacha Bay and poisons sea creatures there. After that, it is diluted, its concentration drops, and it gradually leaves the Avacha Bay. All these events could have happened 1 month or 2 weeks before the visible catastrophe. Contamination spreads out at the bottom, and nobody can notice it. Apparently, something affected it. In other words, there's some substance that does not flow on the surface, but is in fact located somewhere underneath. Nobody except surface noticed anything strange happening with the ocean before the wash-up of the sea creatures to the beach. First complaints were raised by our instructors sometime around September 10th. This can be explained by the big waves at the Khalaktirsky beach, which mix all layers of seawater and bring polluted waters to the top. Surfers are trying to catch that very type of waves. That is why they started to feel something unusual approximately 2 weeks before the catastrophe. Then a storm happened, and we all witnessed the visible part of the Kamchatkan environmental disaster. During the storm at the end of September, waves raised dead aquatic life forms up from the seabed and washed them onto the Halaktyrsky beach, Balshaya Lagernaya and Malaya Lagernaya bays, and also the Babya Bay. Together with the sea creatures, waves raised up the remaining toxic substances from the seabed. After the contact with poisoned water, surface had serious chemical burns and started to report everything that was going on onto the social media. You know what happened next. Now, let's talk to Ilya Sviridov, the witness of those events and the member of our investigative team. Alright, can you tell us about your experiments with sea urchins?
I had indeed met Anton Morozov before October 27th. I had an aqueous phenol solution with me. After I chlorinated the sample, I offered Anton to compare the smell. He said it was remarkably similar to what he experienced at the Halaktyrsky beach. Despite wearing safety glasses, we both felt a burning sensation in the eyes. I also experienced the sensation of a foreign body in my right eye, which lasted for a week. I also experienced gastrointestinal upset, just like after a food poisoning.
Can you tell us about your experiments with sea urchins?
Yes, I experimented with sea urchins and chemicals, chlorphenols in particular. All I managed to achieve was their quick death and bleaching. But for bleaching, the maximum allowable concentration needs to be exceeded by hundreds of thousands of times. And what could be the source of such high phenol amounts in the ocean is a puzzle. As for 2,4-dichlorophenol, there was a source for it. Control sea urchin, which I enclosed in a container with seawater, did not get bleached and was alive for more than 2 weeks.
So there must have been some dichlorophenol leaks, right? Where could they have come from?
Only the Kozelsky toxic waste site could be the source of such a large amount and the variety of toxic chemicals.
Can you tell us what you know about the Kozelsky toxic waste site? What information do you have?
Well, even the report produced in 2002 reads that the leak monitoring inspection identified that the maximum allowable concentration was exceeded in practically every area within 500 meters downstream from the site where samples were collected. The data on the toxic chemical levels in the samples were erased from the reports published in 2015-2017 that are stored on the Kamchatkan government website. From all the reports, every single report. Here are 4 reports from 2015 to 2018. Luckily, we found Ekaterina Kanaykina's article referring to the paper version of those reports. In the article, we can find the history of observations from 2004 through 2018, where we see that the maximum permissible concentration for pesticides such as aldrin and lindane was exceeded. They also found pesticide methylparathion, Metaphos, and herbicide 2,4-D.
Wait a second, you mentioned a very important thing. Data about it is included in the classified report, but is erased from the report posted at the Kamchatka government website. Did I understand you correctly?
Yes, 4 reports.
And all the substances we have found at the laboratory of the Moscow State University is in fact making this data public, right?
Yes.
And the last question. Allegedly, in 2010, this toxic waste site was remediated. I read in the news that 5 billion rubles were allocated for this project.
The Interfax news report that you mentioned reads that construction was finished in 2009 and over 5 billion rubles was spent. Well, in 2009 no work was done on the site, so someone, if we believe this news report, received 5 billion rubles for some kind of preparation for the remediation of soil, which was done in 2010 solely at the expense of the Kamchatka regional budget. Hence, If the 5 billion rubles even existed, not a single penny reached the Kozelsky toxic waste site.
I think this conversation will end up in a case filed to the Russian Federation Investigative Committee.
Indeed.
So what's the final conclusion? According to our theory, the leak of pesticides from the Kozelsky toxic waste site was the reason for the marine life form's death and the poisoning of surfers. The proof is our findings of incredibly toxic substances along the way of their movement to the ocean and the increased content of general phenols in the seawater during the days of the unfolding disaster. It was registered by every laboratory, from the Russian Federal Natural Resources Management Services to Greenpeace. So what should we do with all this knowledge? For you, I recommend that you widely share this video. You know that only a broad public outcry can change the situation on the peninsula. We did a great job and we are confident in our results. We are ready to defend our truth in any court. What should the authorities of the Kamchatka region do with this? The authorities of the Kamchatka region do not necessarily have to agree with our version of the events. It has nothing to do with the red tide theory. Let's assume that more than one scenario, 2, 3, even 4 can play in parallel in nature. This will help us save time for what's really important. I examined the anthropogenic theory, and I strongly recommend that the authorities respond to what we showed in this video. I believe all 3 mentioned sites must be brought to the up-to-date standards of environmental safety as soon as possible, and in general, execute strict control over waste disposal on the peninsula. I also suggest looking into the wastewater treatment system of Petropavlovsk-Kamchatsky. Based on my and others' analysis and visual observations, I can say with confidence that the wastewater treatment facilities of Kamchatka's capital practically do not work at all. This is what wastewater treatment ponds look like. They are all overgrown by bushes. And I'm sorry to say it, the half-decomposed human waste products are floating in the surrounding waters. Now back to the poisoned surfers. We will fight for them in court. I am in touch with their lawyer. I confirmed that I am willing to testify in court as an expert in this criminal case. Some surfers have already received a victim status, and I hope justice will prevail. That is all from me. I will publish a full financial report after I pay all laboratory fees. A few analyses are still in the process, including those from overseas laboratories, for a number of other types of chemical substances. If we find anything interesting, I will tell you about it in my Instagram. That's all for now. Please subscribe to this channel. Soon we will start very interesting and useful work which we environmental scientists will do together with attorneys. I will keep you posted. May the clean air and water be with you. Bye for now.